Now, today, we will talk about the addition rule in probability. Now, the main idea here is the following. We are going to use the addition rule because it states that for any two events, A and B, if we want to find out the probability of events that has the word or, where you have to choose either one or the other, we will use the following formula. The probability of A or B, that is equal to the probability of A, plus the probability of B minus the probability of A and B. Now, this is just a formula that we really need to get familiar with. The probability of A or B, that is equal to the probability of A plus the probability of B minus the probability of A and B. Now, this makes a little bit of sense because here's how we can express that using a Venn diagram. So we have our Venn diagram. Let's say that this is A and this is B. Now, on our previous videos on Venn diagrams, we saw that if we want to use P, A, or B, it's basically this is what we're looking for when we call A or B. Just the insides without touching the intersection. This is probability of A or B. If you're still unclear, please go back and check the video for Venn diagrams. This is A or B. Now, how we can get this shaded region? Well, this shaded region is the whole circle of A, which is P of A, the whole circle of B, which is P of B, so you add them up, minus P, A, and B, but remember that end, we can think about it as an intersection. So you want to find out just these regions, just the regions that we just shaded here. Well, that's the circle of A plus the circle of B minus the middle. And that's what this formula says. P, A, or B, that's equal to P of A plus P of B minus P, A, and B. So it is pretty important for you to get familiar with this formula. Now, we're not going to see it in this video, but I just want to talk about this for a second. There's something called disjoint event. And that is, if two events are disjoint, they mean that they have no outcomes in common. So if two events are disjoint, then if you want to find A or B, you just add up their probabilities. So if two events are disjoint and you want to find the OR probability, you don't have to use this big formula. All you got to do is just add the probabilities in here. We're not going to see it in this video exactly, but I just want you to get exposed to it. If it says disjoint, then we will just add the probabilities. If we want to find the OR probability between two events, if they don't say disjoint, then most likely it's always going to be this formula. So let's see some examples now. So here we have example 1. Now, again, the first thing that you always do is just get familiar with the scenario that we're speaking of. So let's see. Of the works of an art at a large gallery, 59 are paintings and 83 are for sale. When a work of art is selected at random, let the event that it is a painting, so painting, we will use A, and the event that for sale, we're going to use B. Now, our first task here is, let's just find out what P of A and what P of B is. Okay, so we know that A stands for the painting. So P of A is pretty much what is the probability that it is a painting? Well, we know that is 59%. So P of A is 0.59. P of B, what does B stand for? B stands for cell, but I know that the cell is 83%, so that says that P of B is 0.83. Excellent. Now, if we look at example, or at least section B, it says suppose that you are told that P, A, and B is equal to 0.51. But our main task is to find out PA or B. So again, let's see. What is the formula again for PA or B? Let's write them out. Now we know that P, A, or B, this is equal to the probability of the first event plus the probability of the second event minus the probability of the intersection of those two events. So this is the formula that we discussed in the main idea. So now let's see, do we got enough info? Well, let's see, we want to find PA or B. So PA or B, that is equal to P of A, which in this case we know is 0.59. So let's put it here. Plus P of B, but we know that P of B is 0.83. So 0.83 minus PA and B. Now, where can we get this from? They're giving us to us right here. It says PA and B is equal to 0.51. So now, what we have to do is just use our calculator. So let's just find this value, which is equal to 0.91. Now, what this means is that the probability for you to be chosen either a painting or something for sale, that is going to be equal to 0.91. Again, you see how crucial this formula is? We're going to be talking about or. You should start thinking about this formula. If you want to find the events that involve the word or, we got to start thinking about this formula. The probability of the first plus the probability of the second minus the probability of their intersection. So now let's observe another example here. Now notice that here in example 2, again, the first thing that you should do is just get familiar with the setting. So let's see, what are we speaking of here? So it says Josie will soon be taking some exam which deals with mathematics and English. Now she estimates that the probability for her to be passing the math exam is 0.7 and the probability that she passes the Spanish exam is 0.9. She's also willing to assume that the two results are independent from each other. Now, the first thing that we want to do is, using Joe's assumption of independence, we want to calculate the probability that she passes both exams. So pretty much they're asking us here, what is the probability of A and B? Because if you want to pass both exams, is both of them, so that's A and B. So now, why are they saying that we need to use the assumption of independence? Because if you remember on our previous video, when two events are independent, we can multiply their probabilities to find out their AND probability. So what this says is that PA and B, that is equal to the probability of A, which in this case, well, let's write down the formula, times P of B. And this is true because of independence. If they would have not stated that they're independent, then we cannot use this formula. But here they're telling us that they are independent, so we can use this formula. So now let's see. What is the probability for her to be passing the first exam? 0.7. And we're going to multiply this by the probability of the second event, which is 0.9, which this is equal to 0.63. Again, we can use this idea because we want to use the AND. If we use both, then this is pretty much telling you that we need to start thinking about AND probability. Which we use here. And we know that they're independent, so we can just multiply their probabilities. Now, why are they asking us to find that? Because, well, let's look at A. Here it says, find the probability that Josie passes at least one of the exams. Now, when they say that at least one of the exams, that's pretty much it's saying that either she passes math or passes English. So notice here that they're using the word or. So when you see the word or, we got to start thinking about that long formula, which is P of A or B. This is equal to the probability of the first plus the probability of the second minus the probability of their intersection. So now let's see, do we know those values? Well, let's see. Do we know the probability of A? Well, it says the probability of the first event, which is zero point 0.7. So we got zero point 0.7 plus the probability of the second event, which we found it to be 0.9, minus the probability of A and B. But we found this on example A. We know the probability of A and B is equal to 0.63. So we're going to plug that in on our formula. And now, if we evaluate, we get 0.97. So here's your entrance ticket. Given the following, find the probability of A or B.